Dear students, today we are going to derive the famous formula known as Prism formula, and we shall also derive an expression for deviation, angle of deviation in terms of refractive index and prism angle. Well, what is prism and what is prism angle? You see, we have a tent like a structure completely filled with glass. If you say for example, we have a tent like a structure and completely filled by glass, that will be the more or less shape of a prism. Here we are having the front view of the prism, and therefore it looks like a triangle. Otherwise, when we look from the side, we have this type of structure. Three, you see, two faces, and then covered with a flat face filled with glass. So that means roughly it is like a tent house. Well, you see the topmost angle, this angle, the apex angle is known as prism angle, and the lower surface is known as base of the prism. We have considered a light ray incident on the glass prism, which after first refraction moves along direction QR, and after second refraction it moves along direction RS. Well, angle of incidence for the incident ray is taken as I, that is N1QP is angle of incidence, and the corresponding angle of refraction for refraction at the first face AB of the glass prism is taken to be R1. Well, here NQN is the perpendicular drawn at the point of incidence Q. Therefore, angle between the refracted ray and the normal, that is angle RQN, is R1, is the angle of refraction due to first refraction taking place at the first face of the glass prism. Now the light travels within the glass, and finally before emerging out of the glass prism, it again suffers second refraction at the face AC of the glass prism, and the ray is further bending away from the normal. Normal is N2RN at the point of emergence R, and this angle between the emergent ray, that is second refracted ray, and the normal is known as angle of emergence. One thing we can always consider that for vertically opposite angles are equal, therefore N1QP, that is angle I, must be equal to MQN. Therefore, this whole angle MQN is equal to I, and since we have considered angle RQN is R1, therefore the remaining part of this angle must be equal to I minus R1. In the same fashion, the vertically opposite angle, that is N2RS, is equal to emergent angle, must be equal to the vertically opposite angle MRN. And since the angle QRN, angle of incidence for the light ray emerging out of the glass prism, say R2, we have considered, then the remaining part of this angle must be equal to E minus R2. That means angle MRQ is equal to E minus R2, and angle MQR is equal to I minus R1. One thing now we can do is we have marked it as equation number 1. Now we look at a quadrilateral AQNR. In the quadrilateral AQNR, what you see is the sum of the four angles of the quadrilateral must be equal to 360 degree, and therefore we have angle A, that is the prism angle, plus angle N, that is angle QNR, plus angle AQN, that is 90 degree, plus angle ARN, that is 90 degree. So we have angle A plus angle N plus 90 degree plus 90 degree equal to 360 degree, and therefore on subtracting 180 from 360 we get angle A plus angle N is equal to 180 degree. We name it as equation number 2. Now from triangle QNR, we have the sum of all the three angles of the triangle must be equal to 180 degree. So we have R1 plus R2 plus angle N equal to 180 degree. R1 plus R2 plus angle N is equal to 180 degree. We call it equation number 3. When we compare equation 2 and equation 3, both are equal to 180 degree and N is common on both the sides. So we have angle R1 plus R2 equal to angle A, and we call it equation number 4. Finally, from triangle MQR, you see triangle MQR, the upper triangle, you see MQR. From MQR, what you see is the exterior angle, that is angle of deviation. What is the angle of deviation? You see we can have this angle of deviation given by angle TMR, that is the angle by which the original ray was deviated at the time after emerging out of the glass prism. This was the original direction of the light, and this is the final direction of light after emerging out of the glass prism. So the angle between the emergent ray and the original ray incident, that angle is known as angle of deviation. That is the angle by which the light ray is deviated from its original path. So now the exterior angle delta must be equal to sum of interior angle, and so we can write it delta, that is angle of deviation, equal to I minus R1 within bracket plus within bracket E minus R2. So we write I minus R1, we can write it within the bracket plus angle E minus R. So if we now collect I and E together and R1 and R2 together, what we see is, and take minus sign common, we have I plus E minus R1 plus R2 within bracket. And for R1 plus R2, here you see, for R1 plus R2 we have equal to angle A, equation 4. So for R1 plus R2 we write A, and that means delta equal to I plus E minus A. We call it equation number 5. Now you see, we have one situation. If the light emerging out of the glass prism is suffering minimum deviation, then in that case the light ray will have angle of incidence and angle of emergence equal. Why this happens? We can take some analogy with the case of refraction in a glass slab. In a glass slab, you see, light ray is incident on the surface of glass slab. It is bending towards the normal. It is bending towards the normal, and again after emerging out of the glass slab, it occupies the same original direction along which it was incident. It suffers only lateral shift, and there is no change in direction of the light ray. And in this situation, what is happening? The angle of incidence is equal to angle of emergence. And in this situation, there is no deviation. Deviation is 0 because original light ray is emerging along the original path of the incident ray. Only it is having some lateral shift from its original path, but directional change is not there, means deviation is 0. And for minimum deviation, we have angle of incidence is equal to angle of emergence. So from this we have a clue that to have minimum deviation, angle of incidence must be equal to angle of emergence. And for this situation, the first refracted ray, which is moving within the glass prism, must be parallel to the base of the glass prism. If the angle of the two angles of the bases at the bases of the glass prism are equal. So that means for the case of minimum deviation, we can take angle of incidence is equal to angle of emergence, and therefore if we happen to have it I equal to E, therefore we have R1 is equal to R2, because I and E becomes equal, so these two R1 and R2 also becomes equal, and we assume it to be equal to say R, and therefore we have 2R equal to A, because here you see 2R, R plus R is equal to A, therefore 2R is equal to A, therefore R is equal to A by 2. So we got the expression for angle of refraction. The angle of refraction at the time light ray enters the glass prism, and again we have I equal to E. So we have angle of minimum deviation, we have delta equal to I plus E, that means I plus I minus A, and so we have delta equal to, therefore we have I equal to delta M plus A by 2. You see I plus I becomes 2I, and so on changing this side it becomes 2I equal to delta M plus A, and that therefore I equal to delta M plus A whole divided by 2. So we got the value of angle of incidence, we got the value of angle of refraction at the point when light ray is entering the glass medium. So we have refractive index of glass with respect to air equal to sin I by sin R, and sin R, for sin R we have sin A by 2, for R we have A by 2, and for I we have delta M plus A by 2. So we got the expression for refractive index of glass with respect to air is equal to sin delta M plus A by 2 divided by sin A by 2. This is known as Prism formula. We have named it equation number 8. Also, if we take I and R to be very small, what happens? We can write refractive index of glass with respect to air is nearly equal to, because sin I is nearly equal to I if the angle is small. So we have refractive index of glass with respect to air equal to delta m plus a whole divided by 2, and that divided by a by 2. So 2 factor is common, that cancel each other, and it becomes delta m plus a by divided by a, delta m plus a divided by a, and that becomes on changing the side of a in the numerator, you have mu a equal to delta m plus a, and therefore we get delta m equal to mu minus 1 within bracket into a, where mu is the refractive index of glass medium with respect to air medium, and this formula is known as deviation formula. That's all for today. Thank you and have a nice day.